You know that sound, right? That deep, rumbling groan of a diesel engine as a train powers by. For most of us, that's just the sound of a train. It's been that way for decades. But we're living in an age of electric everything, which kind of begs the question,
Seriously, think about it. Electric cars are everywhere now. So it feels a little weird, doesn't it? That so much of our rail network is still chugging along on what feels like old tech. What's the holdup?
Now, the dream, the answer that seems so obvious, is just to electrify every single track. Put up those overhead power lines, the proper term is a catenary system, everywhere. Clean, quiet, efficient trains running coast to coast. Seems like a no-brainer, but, well, that dream hits a brick wall made of reality pretty fast.
And that brick wall is money. A whole lot of it. As this user on the Rail UK forums puts it so well, the cost to do this has just skyrocketed. We're talking about it being extraordinarily expensive. That's not a small problem. That's a deal breaker.
And it's not just the sticker shock. The problems just keep piling on. To install all those wires, you have to shut down active train lines, sometimes for months. That means massive disruptions. Then you've got to pay to maintain all that new hardware, forever. And here's the real kicker. We don't even have enough skilled engineers to do the work in the first place. Okay, so if Plan A, stringing up wires across the entire country, is pretty much off the table, we've got to find a Plan B. This challenge has kicked off a huge search for the next generation of train tech, and right now there are two major contenders stepping into the ring.
First up, we have the one that probably popped into your head already, the battery train. I mean, it works for cars, so why not for a train?
But let's keep our feet on the ground here. I love this quote from another forum member, "They're a big part of the future, but they're not magic." And that's exactly right. Battery trains are an incredible piece of the puzzle, but they're not some magic wand you can just wave at every problem on the network.
So how do they work? Well, the idea is actually pretty clever and simple. On the main lines that already have the overhead wires, the train runs just like a normal electric train and it charges up its onboard batteries while it's moving. But then, when it gets to a smaller branch line where the wires stop, it just seamlessly switches over to battery power. It can even squeeze out a bit more range by using regenerative braking, just like a hybrid car does.
And this is where they really shine. You can get these trains on the tracks way faster and cheaper than a full electrification project. You don't have to shut down lines or build tons of new infrastructure. You just need the trains. Plus, we get to piggyback on all the incredible battery research and development that the electric car industry has been pouring billions into for years.
But what about the really tough jobs? The long-distance routes, the heavy freight trains, those steep mountain climbs where a battery just isn't going to cut it. For those, we need to look at our second solution, hydrogen.
And nope, this isn't some far-off sci-fi concept. It's happening right now. Just look at this map from a European rail study. All across the continent, real-world hydrogen train projects are already in the works, and they're specifically targeting those tricky routes where batteries just can't go the distance. To really see what this is all about, let's zoom in on a perfect example. We're going to look at a really challenging line in Spain, running from the city of Zaragoza all the way up into the Pyrenees Mountains. It's the perfect test for this kind of technology.
And this route is an absolute beast. It's long, it's remote, and just look at that elevation profile. It's a relentless climb of over 1,000 meters. Can you imagine trying to build overhead power lines all the way up there? It would be a total nightmare, both financially and for the environment. This is exactly the kind of job that screams out for a different solution. So, what even is a hydrogen train? Well, think of it like an electric train with its own personal power plant on board. It's still driven by electric motors, but instead of getting power from a wire, it makes it on the fly. It takes hydrogen stored in tanks, mixes it with plain old oxygen from the air, and a fuel cell converts that into electricity. And the only thing that comes out of the exhaust pipe? Water. That's it.
So what does that mean in the real world? What's the impact of swapping out diesel for hydrogen on just this one tough route in Spain? Well, the study ran the numbers on the potential CO2 savings by 2030, and the figure they came up with is just wow. Almost 7,000 tons of CO2. Let that sink in. That's the savings from one single line. Now, just imagine replicating that across hundreds of similar remote or difficult routes all over the world. Suddenly you start to see the absolutely massive potential here.
So, we've got two incredible technologies, right? Batteries and hydrogen. But here's the thing, you can't just use them interchangeably. To really get what the future of rail looks like, we've got to put them head to head. And this table just lays it out perfectly. On one side, you've got battery trains. They're the sprinters. They are perfect for shorter trips, those little branch lines that peel off the main network.
but their range is limited, maybe 70 kilometers or so. On the other side, you've got hydrogen trains. They are the marathon runners, built for the long haul. We're talking over 700 kilometers, and for heavy-duty jobs. A battery train has to stop to recharge, which can mess up tight schedules. A hydrogen train, it refuels in minutes, almost exactly like a diesel train does today.
In fact, the experts who did that big European study drew a really clear line in the sand. They basically said that for the really big jobs, like mainline freight locomotives, batteries just aren't a viable option right now. You'd need a battery so massive and heavy, it just wouldn't be practical. It makes it crystal clear. Each technology has its own lane.
So where does all this lead us? Well, it's not about one technology winning and the other one losing. The real future of rail is actually way more clever than that. It's about building a smarter, more flexible network using a patchwork of solutions.
And honestly, that forum user, Zonboyd, absolutely nailed it with his comment. A sensible world uses the right tool for the right job. You electrify the super busy main arteries, you use batteries for the smaller local routes, and you bring in something like hydrogen for those really long, tough, remote journeys. It just makes sense.
And this is pretty much the game plan. You get this elegant three-tiered system. Step 1. The core highways of the rail network. The busiest routes get full electrification. Step 2. Battery trains act as the perfect connection for all the regional lines that branch off that main grid. And Step 3. For everything else, the cross-country freight, the epic passenger journeys, the mountain passes, hydrogen trains step in to do the heavy lifting.
So you see, the goal isn't to just find one single replacement for diesel, it's about weaving together this amazing tapestry of technologies, where each one plays to its own strengths. The result is a rail network that's not just cleaner, but smarter and more resilient than anything we've had before.
Which leaves us with one final big thought to chew on. On the surface, this is all about replacing diesel. But what if it's bigger than that? As this new generation of clean, quiet, and incredibly versatile trains starts to roll out across the world, could they do more than just clean up our act? Could they fundamentally reinvent the entire experience of train travel as we know it?